February 1965. Viet Cong fighters crouched in thick jungle canopy, watching American soldiers hack through vines with machetes. Down below, GIs stumbled around, clearing small patches of mud, setting up canvas tents that screamed, "Temporary." Charlie couldn't believe what he was seeing. These soft Americans were building camps like they were on some camping trip back home. Flimsy perimeters, predictable layouts, easy targets. "Look at them," one VC commander whispered to his men. "They can't build anything that lasts in our jungle." But in 72 hours, everything would change. The Americans were about to unleash something that would turn this guerrilla war upside down. When American forces first landed in Vietnam, they brought a World War II playbook to a guerrilla fight. These guys had stormed beaches in the Pacific, built massive bases across Europe. They figured Vietnam would be more of the same. They were dead wrong. The first American camps in Vietnam looked like disasters waiting to happen. Tents scattered around clearings, sandbag walls that took weeks to build properly, supply dumps sitting out in the open like Christmas presents for the Viet Cong. February 7, 1965, Camp Holloway near Pleiku. The Viet Cong hit the base with mortars and satchel charges, killing 8 Americans and wounding over 100. The attack lasted 15 minutes. 15 minutes to tear apart weeks of American construction. 3 days later, they hit the Pleiku barracks. More dead Americans, more destroyed equipment. The pattern was becoming crystal clear. American troops would spend weeks building these vulnerable camps, and Charlie would waltz in and destroy them overnight. It was like watching a slow-motion disaster. Colonel William Dupuy, later a general, put it bluntly. "We were sitting ducks. Our camps were predictable, slow to build, and impossible to defend properly." The problem wasn't just the camps themselves, it was the entire American approach to warfare in Vietnam. These engineers had built the Alaska Highway, constructed airfields across the Pacific during World War II, but Vietnam's jungle wasn't Alaska's tundra or some Pacific island. This was Charlie's backyard. Every trail, every ridge, every stream. The Viet Cong had been fighting in this terrain for decades. They knew exactly where Americans would build camps, how long construction would take, and when to strike for maximum damage. American casualties started climbing fast, not just from combat patrols, but from attacks on these vulnerable base camps. Soldiers were getting picked off while they slept, while they ate, while they tried to build some basic defenses. The psychological impact was devastating. American troops couldn't relax anywhere. Every night brought the possibility of mortars raining down on their flimsy camps. Every day meant working on defenses that might not be finished before Charlie struck again. Military brass back in Saigon were getting desperate. Reports from field commanders. "We need better bases, and we need them fast. Our current construction methods are getting people killed." Traditional military engineering doctrine said you needed months to build a proper fire base, months to survey the terrain, design the layout, bring in materials, construct proper defenses. But months meant more dead Americans while Charlie picked them off from the jungle. Something had to change, and it had to change fast. The Viet Cong were winning this construction war before it even started. Their tunnel networks had taken years to perfect, but they were invisible, sophisticated, and deadly effective. Meanwhile, American camps stood out like neon signs in the jungle. By spring 1965, it was obvious that America's traditional military engineering was completely useless in Vietnam. The enemy wasn't going to line up for conventional battles. They were going to hit American bases when and where it hurt most. The Pentagon was facing a brutal reality. Either figure out how to build defendable positions fast, or watch American casualties mount while the Viet Cong picked apart every vulnerable camp. What nobody knew yet was that a group of combat engineers was already working on something revolutionary, something that would turn Charlie's tactical advantage into his worst nightmare. Enter the 18th Engineer Brigade. These weren't your typical construction workers with hard hats and coffee breaks. These were combat engineers, guys who built bridges while getting shot at, cleared minefields under fire, and treated bulldozers like weapons of war. Colonel Robert Ploger got the call in March 1965. His mission: figure out how to build defendable American positions in Vietnamese jungle before more soldiers died in vulnerable camps. Ploger looked at his roster. These were the same engineers who'd carved the Alaska Highway through frozen wilderness during World War II. Men who'd built airfields on Pacific islands while Japanese planes strafed them. But Vietnam was different. This wasn't about building permanent infrastructure. This was about survival. "Gentlemen," Ploger told his officers at their first briefing in Saigon, "we need to build bases faster than Charlie can destroy them. And we need to do it while he's shooting at us." The 18th Engineer Brigade wasn't just moving dirt. They were America's answer to guerrilla warfare, precision engineering meeting jungle combat in ways nobody had ever attempted. Captain James Morrison, a combat engineer who'd survived Normandy, described the culture clash. "In Europe, we had months to plan, weeks to build. Here, you had hours to plan and had to finish before dawn, or you'd wake up dead." These engineers came from American construction sites, highway projects, dam building. They understood concrete and steel, bulldozers and cranes. But Vietnamese jungle played by different rules. The humidity destroyed equipment in days. Monsoon rains turned construction sites into swamps overnight. And unlike World War II, where front lines stayed relatively stable, Vietnam had no front lines. The enemy could appear anywhere, anytime. First attempts at rapid construction failed spectacularly. Engineers would start building a fire base, only to get hit by mortars before they'd finish the perimeter. They'd bring in heavy equipment, and Viet Cong sappers would blow it up the same night. Lieutenant Colonel David Hughes, Ploger's deputy, kept detailed records of these early disasters. March 15th, lost 2 bulldozers to satchel charges. March 18th, mortar attack destroyed prefab materials. March 22nd, sniper fire halted construction for 6 hours. The problem wasn't lack of skill or equipment. American engineers had both in abundance. The problem was time. Traditional construction methods required weeks of vulnerable exposure while building. In Vietnam, that meant certain death. But these combat engineers had something Charlie didn't expect: American ingenuity under pressure. They started thinking outside every construction manual ever written. What if they could prefabricate entire bunker sections back at secure bases, then helicopter them into position? What if they could build modular defensive systems that snap together like giant Lego blocks? Staff Sergeant Mike Romano, a veteran of Pacific Island construction, had the breakthrough. "We're thinking like civilian contractors. We need to think like combat soldiers who happen to know construction." The 18th Engineer Brigade started experimenting with revolutionary concepts. Instead of building from the ground up, they'd build from the sky down. Instead of weeks-long construction projects, they'd aim for hours. By summer 1965, Ploger's engineers were developing techniques that would make military history. They were combining helicopter logistics with prefabricated construction, creating something nobody had ever attempted: instant fortresses. The Viet Cong had spent years perfecting their tunnel networks and jungle tactics. Now, they were about to face American engineers who could build defendable positions faster than Charlie could plan attacks against them. These weren't just construction workers anymore. They were combat engineers who understood that, in Vietnam, the difference between fast construction and slow construction was the difference between life and death. The 18th Engineer Brigade was about to change the rules of jungle warfare forever. To understand why American engineers had to revolutionize military construction, you need to see what they were up against. The Viet Cong weren't just random guerrillas hiding in the jungle. They were masters of their environment who'd been perfecting their tactics for decades. The Ho Chi Minh Trail wasn't just a supply route. It was the ultimate logistical masterpiece. While Americans struggled to move equipment through thick jungle, Charlie had created a hidden highway system that stretched from North Vietnam all the way down to the Mekong Delta. This wasn't some dirt path through the trees. The trail included underground fuel depots, hidden repair shops, camouflaged rest stations, and supply caches that could sustain major military operations. American bombers would hit sections of the trail only to find them rebuilt and operational within days. But the real genius was underground. Viet Cong tunnel networks represented years of patient, methodical construction. These weren't simple hiding holes. They were sophisticated underground cities with multiple levels, ventilation systems, command centers, hospitals, and weapons storage. The Suchi tunnels alone stretched over 150 miles underground. Charlie could disappear into these networks, pop up miles away, hit American positions, then vanish again before reinforcements arrived. American soldiers would sweep an area, declare it secure, then get hit by enemies who seemed to materialize from thin air. Local knowledge gave the Viet Cong every possible tactical advantage. They knew which ridges provided the best observation points, which valleys flooded during monsoon season, which trails could support heavy equipment. When Americans picked locations for new camps, Charlie could predict exactly where they'd build and how long construction would take. Vietnamese farmers who worked rice paddies during the day became intelligence gatherers at night. They'd watch American construction activities, count equipment, observe security procedures, then report everything back to Viet Cong commanders. This intelligence network meant Charlie knew about American construction projects before the concrete dried. They'd plan attacks based on detailed knowledge of camp layouts, defensive positions, and supply schedules. The psychological warfare was just as devastating as the physical attacks. Americans never knew when or where the next strike would come. Soldiers would work on base construction during the day, then lie awake at night listening for incoming mortars. Charlie perfected the art of making Americans afraid to sleep. Random sniper shots would ring out just as soldiers started to relax. Mortars would land just outside base perimeters, close enough to keep everyone on edge, but not close enough to trigger major retaliation. The Viet Cong understood that destroying American morale was more valuable than destroying American equipment. A demoralized soldier makes mistakes, loses focus, becomes careless about security procedures. Traditional military engineering assumed you had secure rear areas where construction could proceed safely. Vietnam had no rear areas. The entire country was a potential battlefield where enemies could strike from any direction at any time. American engineers trained on construction projects where the biggest threat was bad weather or equipment failure. In Vietnam, they faced an enemy who specifically targeted construction sites, knowing that half-built bases were the most vulnerable targets. The timing of Viet Cong attacks wasn't random. Charlie would wait until American construction reached critical phases, when defensive positions were partially complete but not yet operational, when supply dumps were full but not yet secured, when communication systems were installed but not yet fully tested. This tactical patience drove American commanders crazy. They'd rush construction to minimize exposure time, which led to mistakes and structural problems. They'd slow construction to ensure quality, which gave Charlie more opportunities to strike. The Viet Cong had turned the construction process itself into a weapon against American forces. Every day spent building a fire base was a day of vulnerability, a day when Charlie could choose the time and place of attack. By late 1965, it was clear that traditional military engineering couldn't compete with guerrilla warfare tactics, perfected over decades of fighting. American engineers needed to completely rethink their approach to construction in hostile territory. The Viet Cong advantage seemed insurmountable. They had home field advantage, perfect intelligence, unlimited patience, and tactics specifically designed to exploit American construction vulnerabilities. But they didn't know what American engineers were planning next. March 15, 1966, Operation Masher was grinding through Binh Dinh province when everything changed. Colonel Ploger's engineers were about to attempt something that military textbooks said was impossible, building a fully operational fire base in under 6 hours. The target location was a hilltop designated Fire Base Alpha, 15 miles northwest of An Khe. Intelligence reports indicated heavy Viet Cong activity in the area, which meant traditional construction methods would get people killed before the first bunker was finished. But Ploger's team had been preparing for this moment. Back at their secure base in Quy Nhon, combat engineers had spent weeks prefabricating modular bunker sections, pre-engineering artillery positions, and designing a construction sequence that could turn jungle into fortress before Charlie knew what hit him. The operation began at 600 hours with CH-47 Chinook helicopters thundering toward Firebase Alpha, carrying the first wave of prefabricated sections. These weren't just supplies. They were entire bunker walls, complete with reinforced steel frames and firing ports already cut to specification. Staff Sergeant Romano watched the first Chinook approach the hilltop. That bird was carrying a command bunker that weighed 8,000 pounds, complete unit, walls, roof, steel reinforcement, everything. We'd hook it up, set it in position, and bolt it down. 15 minutes later, you had an operational command post. The second wave brought something even more revolutionary: prefabricated steel landing mats that could create an instant airstrip. These interlocking steel plates had been used in World War II for temporary airfields, but nobody had ever tried deploying them by helicopter into a combat zone. Combat engineers hit the ground running. While some teams positioned the prefab bunker sections, others were laying out the steel matting for the airstrip. Within 2 hours, Firebase Alpha had a landing zone capable of handling C-130 cargo planes. The third wave brought the artillery. 105mm howitzers were pre-positioned on specially designed concrete pads that had been cast at the rear base, then flown in as complete units. The guns were operational within 3 hours of the first helicopter landing. But the real breakthrough was the defensive perimeter. Instead of spending days filling sandbags and digging fighting positions, engineers deployed prefabricated defensive sections that interlocked like puzzle pieces. Each section included overhead cover, firing ports, and communication lines already installed. Captain Morrison coordinated the perimeter construction. We had defensive positions going up faster than Charlie could figure out what we were building. By hour 4, we had interlocking fields of fire covering every approach to the hilltop. The Viet Cong scouts who'd been watching American construction for months couldn't believe what they were seeing. Where they expected weeks of vulnerable construction activity, they found a fortress materializing in real time. Radio intercepts later revealed Charlie's confusion. American position becoming very strong, very fast, cannot determine construction timeline, recommend immediate attack before completion. But it was already too late. By hour 5, Firebase Alpha had operational artillery, secure ammunition storage, helicopter landing zones, and defensive positions that could stop a regiment-sized assault. The 6th hour brought the final touches: communication equipment, medical facilities, and supply storage. All prefabricated modules that plugged into the base infrastructure like components in a giant machine. At 1200 hours, exactly 6 hours after the first helicopter landed, Firebase Alpha was declared fully operational. Colonel Ploger received the radio transmission: Alpha base operational, all systems green, ready for combat operations. The psychological impact on American forces was immediate. For the first time since arriving in Vietnam, soldiers watched their engineers build something faster than the enemy could destroy it. The constant fear of working on vulnerable construction projects began to fade. More importantly, the Viet Cong tactical advantage had just evaporated. Charlie's entire strategy depended on hitting American positions during their vulnerable construction phases. Firebase Alpha had eliminated that vulnerability completely. The prefabricated construction techniques developed for Firebase Alpha would revolutionize military engineering. What took weeks using traditional methods now took hours using modular systems designed for rapid deployment. Within days, reports from Firebase Alpha confirmed the breakthrough's success. Viet Cong probing attacks were repelled easily by the base's interlocking defensive positions. Charlie's intelligence network was reporting back to commanders that American construction capabilities had fundamentally changed. The era of vulnerable American camps was over. The age of instant fortresses had begun, and the Viet Cong were about to learn that their tactical advantages were disappearing as fast as American engineers could build. The success of Firebase Alpha wasn't luck. It was the result of revolutionary engineering techniques that turned traditional military construction upside down. What Colonel Plozier's team had developed was nothing short of a complete reimagining of how to build in combat zones. The breakthrough started with modular construction principles borrowed from civilian prefab housing, then adapted for military specifications that could withstand mortar attacks and small arms fire. Every component was designed to serve multiple functions while fitting together with mathematical precision. Captain Morrison explained the system. We treated each fire base like a giant three-dimensional puzzle. Every bunker section, every defensive position, every piece of infrastructure was pre-engineered to connect with every other piece. No wasted motion, no improvisation under fire. The bunker systems were masterpieces of compact engineering. Each prefabricated section weighed exactly what a CH-47 Chinook could carry safely. The walls were reinforced concrete with embedded steel framework, but they were hollow-core construction to minimize weight while maximizing protection. More importantly, every bunker section included pre-installed electrical conduits, communication lines, and ventilation systems. When sections bolted together, all the infrastructure connected automatically. No separate wiring jobs, no additional plumbing work. Everything was integrated from the factory. The steel landing mats represented another engineering revolution. These interlocking plates had been perfected during World War II, but Vietnam engineers modified them for helicopter delivery. Each mat section locked into adjacent sections with precision machine connectors that created seamless airstrips capable of handling heavy cargo planes. Staff Sergeant Romano supervised the mat installation teams. Those steel plates were like giant Lego blocks for adults. Drop them in the right sequence, lock them together, and you've got a runway that can handle a C-130. The whole process took 90 minutes from first plate to operational airstrip. But the real innovation was helicopter logistics coordination. Traditional construction required ground transportation of materials, which meant roads, convoys, and vulnerable supply lines. The new system eliminated ground logistics completely. Everything came by air. Concrete sections, steel reinforcement, ammunition storage containers, communication equipment, even prefabricated latrines, all designed for helicopter delivery and rapid assembly. The CH-54 Sky Crane helicopters could lift 10-ton loads with pinpoint accuracy. These massive birds would hover over construction sites while engineers guided prefab sections into exact positions using hand signals and radio coordination. Lieutenant Colonel Hughes coordinated the helicopter operations. We had Sky Cranes delivering bunker sections, while Chinooks brought in the steel matting, and Huey's provided security overwatch. It was like watching a perfectly choreographed construction ballet performed at combat speed. The ammunition storage systems were engineering marvels in themselves. Instead of building traditional powder magazines that took weeks to construct safely, engineers developed modular underground storage containers that could be buried and operational within hours. These containers were pre-engineered with blast-resistant construction, climate control systems, and security features. Drop them in pre-dug holes, connect the access tunnels, and you had ammunition storage that met all military safety specifications. Artillery positions received the same modular treatment. Instead of surveying terrain and pouring concrete foundations over several days, engineers used prefabricated concrete pads with pre-calculated firing angles and ammunition storage integrated into the design. The 105mm howitzers could be positioned and operational within minutes of delivery. The concrete pads provided stable firing platforms, while underground ammunition feeds eliminated the need for exposed supply runs during combat operations. Communication systems were completely integrated into the modular construction. Every bunker section included pre-installed antenna mounts, radio equipment spaces, and hardened communication lines that connected automatically when sections were assembled. The psychological impact on combat engineers was transformative. Instead of spending weeks exposed to enemy fire while building vulnerable positions, they were creating fortresses faster than Charlie could organize attacks against them. Sergeant First Class Tommy Williams, a combat engineer who worked on Firebase Alpha, described the feeling, "For the first time in Vietnam, we were building faster than they could destroy. We weren't sitting ducks anymore. We were the hunters." The modular construction techniques developed in Vietnam would influence military engineering for decades. The principles of rapid assembly, helicopter logistics, and integrated systems became standard doctrine for combat construction worldwide. But in 1966, these innovations were about survival. American engineers had figured out how to build the impossible, fortresses that rose from jungle mud in hours instead of weeks. April 12, 1966. Intelligence reports were flooding into Saigon from Viet Cong sources around Tay Ninh province. Americans building something big, building it fast, different from before. Charlie's commanders weren't taking any chances. They'd watched Firebase Alpha go operational in 6 hours, but that could have been a fluke. Maybe the Americans got lucky with weather, timing, and lack of interference. This time would be different. The target was Firebase Charlie, positioned on a strategic hilltop overlooking Highway 22, a critical supply route the Viet Cong used for moving weapons and personnel between Cambodia and Saigon. If Americans could establish a permanent firebase there, it would cut Charlie's logistics in half. Viet Cong planning began immediately. This wouldn't be another probing attack with mortars and satchel charges. This would be a full-scale assault designed to overrun the American position before their construction could be completed. Colonel Nguyen Van Duc commanded the 271st Viet Cong Regiment, veterans of jungle warfare who'd been fighting Americans for over a year. His battle plan was simple: hit the construction site during the vulnerable early hours before defensive positions were operational. "These Americans think they can build fortresses in our jungle," Duke told his officers. "We will show them that speed means nothing when you're building on ground we control." The assault force included over 800 Viet Cong fighters, mortar teams, sapper units, and heavy weapon squads. They positioned themselves around Firebase Charlie's hilltop during the night of April 11th, waiting for the first American helicopters to arrive. At about 5:30 hours on April 12th, the CH-47 Chinooks thundered toward the hilltop right on schedule. Duke's forces opened fire immediately, expecting to catch American engineers in the vulnerable early stages of construction. Instead, they found something that shattered every assumption about American military engineering. The first wave of helicopters didn't carry engineers and construction materials. They carried complete defensive bunker sections that were operational within minutes of touchdown. While Viet Cong fighters were still adjusting their mortar ranges, American positions were already returning accurate fire. Staff Sergeant Romano was on the ground with the first wave. "Charlie hit us with everything he had, but our bunkers were already in position and operational. Instead of catching us building, he found us ready to fight." The second wave brought artillery positions that were firing support missions within 30 minutes of arrival. The prefabricated concrete pads allowed 105mm howitzers to engage Viet Cong positions with devastating accuracy, while enemy fighters were still trying to figure out how American defenses had appeared so quickly. Duke's assault plan had assumed hours of vulnerable construction time before American positions became dangerous. Instead, his fighters found themselves attacking a fortress that was growing stronger by the minute while returning increasingly effective fire. The psychological impact on Viet Cong fighters was immediate and devastating. These were veterans who'd spent months studying American construction patterns, learning to time their attacks for maximum effectiveness. Suddenly, all their tactical knowledge was useless. Radio intercepts captured Charlie's confusion during the battle. American positions very strong, very fast, cannot penetrate defenses, request immediate withdrawal. But withdrawal wasn't simple. Firebase. Charlie's rapid construction had included interlocking fields of fire that covered every approach to the hilltop. Viet Cong fighters who'd advanced expecting to overrun a construction site found themselves trapped in killing zones created by prefabricated defensive positions. The battle lasted 6 hours. When it ended, over 200 Viet Cong fighters lay dead around Firebase Charlie's perimeter. American casualties, 12 wounded, 0 killed. More importantly, Firebase Charlie was fully operational by sunset on April 12th. What should have been a vulnerable construction site had become an impregnable fortress in less time than it took Charlie to organize a proper assault. Colonel Duke's after-action report to his superiors was brutally honest. American construction capabilities have fundamentally changed. Previous tactics no longer effective. Recommend immediate tactical reassessment. The first real test of rapid firebase construction had succeeded beyond all expectations. Charlie's confidence in attacking American positions during construction was shattered. The tactical advantage that had sustained Viet Cong operations for years was disappearing as fast as American engineers could build. The success at Firebase. Charlie proved that rapid construction worked, but it also revealed the true heroes of this engineering revolution, the helicopter pilots who turned construction sites into three-dimensional battlefields. The CH-54 Sky Crane was never designed for what American pilots were doing with it in Vietnam. This massive helicopter could lift 10 tons of cargo with surgical precision, but flying construction missions under enemy fire pushed both machine and pilot beyond all design specifications. Chief Warrant Officer Rick Patterson flew Sky Cranes for the 1st Cavalry Division. We weren't just delivering cargo anymore. We were construction foremen working at 3,000 feet while Charlie shot at us. You had to position a bunker section within inches of its foundation while taking small arms fire from 3 directions. The logistics coordination required split-second timing between multiple aircraft types. Sky Cranes carried the heavy prefab sections, CH-47 Chinooks brought medium-weight materials, and UH-1 Hueys provided security overwatch. All 3 had to work together in tight airspace while under fire. Captain Mike Rodriguez coordinated helicopter construction operations. Picture trying to assemble a giant puzzle while riding a roller coaster during an earthquake. That's what it felt like, building fire bases by helicopter in a combat zone. The Sky Crane pilots developed techniques that weren't in any flight manual. They learned to approach construction sites from different angles to avoid predictable flight patterns that Viet Cong gunners could target. They mastered precision hovering, while combat engineers guided heavy loads into exact positions using hand signals. But the real innovation was combat construction under fire. Traditional doctrine said, you secured an area completely before beginning construction operations. Vietnam helicopter pilots were building while fighting, often delivering bunker sections while their door gunners engaged enemy positions. Warrant Officer Janet Morrison became legendary for her precision under fire. I once delivered 6 bunker sections to Firebase Delta while a mortar attack was in progress. The engineers on the ground were taking cover between deliveries, but we kept the construction schedule on track. The psychological impact on Viet Cong fighters was devastating. They'd grown accustomed to American helicopters being vulnerable during landing and takeoff operations. Suddenly, these same helicopters were delivering fortress components faster than Charlie could organize effective countermeasures. The CH-54's lifting capacity revolutionized what could be considered portable military construction. Entire command bunkers weighing 8 tons could be positioned with pinpoint accuracy. Ammunition storage containers that would have required weeks of ground construction could be buried and operational within hours. The Sikorsky S-64 operations pushed helicopter technology to its absolute limits. These birds were flying multiple sorties per day, carrying maximum loads, operating in hostile territory where mechanical failure meant certain death for the crew. Maintenance crews worked around the clock, keeping the sky cranes operational. Chief Mechanic Tommy Williams described the pressure. These birds were flying missions that should have required major maintenance every few flights. We were performing miracles with spare parts and determination. The Viet Cong response was swift and deadly. Anti-aircraft weapons that had been positioned to harass American transport flights were now specifically targeting construction helicopters. Charlie understood that stopping the sky cranes meant stopping the fortress construction, but American pilots adapted faster than enemy gunners could adjust. They varied approach routes, used terrain masking, coordinated with artillery strikes on suspected anti-aircraft positions, and developed evasive maneuvers while carrying 10-ton loads. The helicopter revolution changed military engineering forever. What had been ground-based, time-intensive construction became airborne, rapid deployment fortress building that could outpace enemy tactical responses. By summer 1966, sky crane operations were delivering complete firebase components faster than the Viet Cong could plan attacks against them. The age of vulnerable American construction sites was ending, replaced by aerial construction operations that turned jungle hilltops into fortresses before Charlie could blink. Step inside a completed firebase, and you'd understand why the Viet Cong stopped laughing at American engineering. These weren't just military bases. They were integrated fortress systems designed by combat veterans who understood exactly how Charlie fought. The bunker construction represented a quantum leap beyond anything built in previous wars. Each prefabricated section used reinforced concrete with embedded steel mesh that could stop direct hits from 120mm rockets. But the real genius was in the interconnected design. Every bunker connected to every other bunker through underground tunnels lined with steel culverts. Charlie could destroy individual positions, but he couldn't isolate American defenders or cut their communication lines. The entire firebase functioned as one massive defensive organism. Staff Sergeant Williams supervised bunker installation at Firebase Delta. You could move from the command post to any fighting position without exposing yourself to enemy fire. Underground ammunition feeds meant we never ran out of bullets during firefights. The fields of fire were mathematically calculated for maximum effectiveness. Combat engineers used surveying equipment to ensure every defensive position could support adjacent positions with overlapping fire zones. There were no dead spaces where enemy fighters could advance undetected. Artillery positions were integrated into the defensive design from the beginning. The 105mm howitzers weren't just placed randomly on hilltops. They were positioned to provide direct fire support for the perimeter defenses while maintaining their primary mission of supporting operations throughout the surrounding area. Captain Morrison explained the artillery integration. Our guns could fire high-angle missions against targets 20 miles away, then lower their tubes and blast enemy positions trying to breach our perimeter. Same weapons, dual mission capability. Underground ammunition storage eliminated the vulnerability that had plagued earlier American bases. Instead of exposed supply dumps that made tempting targets, fire bases stored their ordnance in reinforced underground bunkers with multiple access points and blast-resistant construction. The storage systems were engineering marvels. Climate-controlled environments kept ammunition stable in tropical humidity. Multiple compartments prevented chain reactions if one section took a direct hit. Automated inventory systems tracked every round, every grenade, every piece of equipment. Helicopter landing zones received the same integrated treatment. The steel matting created all-weather airstrips, but the real innovation was in defensive positioning. Landing zones were surrounded by bunker positions that could provide covering fire for aircraft during vulnerable landing and takeoff operations. Communication systems represented another breakthrough in military engineering. Every bunker included hardened communication lines that connected to the base communication center through underground cables. Radio antennas were positioned on multiple bunkers to provide redundant communication capabilities. Lieutenant Colonel Hughes designed the communication integration. Charlie could knock out individual antennas, cut some cables, even destroy the primary communication bunker. But he couldn't silence our communications completely. We had backup systems for our backup systems. The perimeter defenses combined multiple obstacle systems that channeled enemy attacks into predetermined killing zones. Concertina wire created the first barrier, but behind it lay anti-personnel mines, punji stakes, trip flares, and claymore mine positions controlled from the bunkers. Medical facilities were built into the firebase design from the beginning. Underground aid stations with surgical capabilities meant wounded soldiers could receive immediate treatment without evacuation. Medical bunkers included operating rooms, recovery areas, and helicopter landing pads for emergency evacuations. Water and power systems were completely self-contained. Diesel generators provided electricity for the entire base, with backup generators in separate bunkers. Water storage tanks were buried underground and connected to purification systems that could handle contaminated local water sources. The psychological impact on American soldiers was transformative. For the first time in Vietnam, they were fighting from positions that felt genuinely secure. The constant fear of enemy infiltration and surprise attacks began to fade when soldiers realized their bases were actually stronger than anything Charlie could throw at them. More importantly, these fortresses changed the tactical balance of the war. Viet Cong fighters who'd grown accustomed to hitting vulnerable American positions suddenly faced integrated defensive systems that could absorb major attacks and return devastating firepower. The engineering that went into these fire bases represented the best of American military innovation under pressure. Combat engineers had created fortress systems that combined rapid construction with defensive capabilities that made them essentially unbreachable by conventional guerrilla tactics. January 21, 1968. The North Vietnamese Army had surrounded the Marine base at Khe Sanh with 40,000 troops, the largest concentration of enemy forces in the entire Vietnam War. What followed would become the ultimate test of everything American engineers had learned about rapid fortress construction. Khe Sanh wasn't built using the new firebase techniques. It was an older base that had been constructed using traditional methods over several months. But when General Giap's forces surrounded the Marines, military engineers had to rapidly upgrade the base's defenses while under constant bombardment. The siege began with a coordinated artillery barrage that destroyed the main ammunition dump in a spectacular explosion visible from miles away. Over 300 tons of ordnance went up in a fireball that shook the entire base and left a crater where the supply depot used to be. Colonel David Lowndes commanded the 26th Marine Regiment defending Khe Sanh. We went from having months of supplies to having days of supplies in about 30 seconds. Everything we'd built over months was gone, and Charlie was just getting started. But the Marines had something their predecessors didn't have in earlier Vietnam battles: combat engineers who'd perfected rapid construction techniques at dozens of fire bases across South Vietnam. The 11th Engineer Battalion arrived within 48 hours of the siege beginning. The engineering challenge was unprecedented. These combat engineers had to rebuild Khe Sanh's defenses while under constant artillery bombardment from North Vietnamese guns positioned in the surrounding hills. Traditional construction was impossible. Engineers were working in underground bunkers during the day and only surfacing at night. The prefabricated bunker systems that had revolutionized firebase construction became lifesavers at Khe Sanh. CH-53 helicopters braved intense anti-aircraft fire to deliver complete bunker sections that could be installed in hours rather than days. Staff Sergeant Rodriguez supervised bunker installation under fire. We'd wait for breaks in the bombardment, then sprint out and bolt down bunker sections. 15 minutes later, Marines had overhead cover that could stop direct hits from 130mm artillery. The underground tunnel systems became Khe Sanh's salvation. Using techniques perfected at other fire bases, engineers connected every defensive position through reinforced underground passages. Marines could move between positions, resupply ammunition, and evacuate wounded without exposing themselves to enemy fire. The ammunition storage problem was solved using modular underground containers that had been developed for rapid fire-base construction. These blast-resistant storage units were buried throughout the base perimeter, eliminating the vulnerability of centralized ammunition dumps. Captain Morrison coordinated the underground construction. We turned Khe Sanh into an underground fortress. Charlie could pound the surface all day long, but underneath we had a complete military city with command centers, aid stations, ammunition storage, and communication facilities. The artillery positions received special attention. The base's 105mm howitzers were repositioned using prefabricated concrete pads that could be installed overnight. More importantly, the guns were protected by specially designed bunkers that allowed them to fire while remaining protected from counter-battery fire. The helicopter landing zones were completely rebuilt using steel matting, systems that could handle the massive C-130 cargo planes needed to resupply the besieged base. These airstrips were constructed under fire, with engineers working between artillery barrages. The psychological impact of rapid construction was enormous. Marines watched their base transform from a vulnerable target into an underground fortress while the siege continued. Morale improved dramatically as soldiers realized their positions were becoming stronger, not weaker, despite constant enemy bombardment. The North Vietnamese response revealed their frustration with American engineering capabilities. Artillery barrages increased in intensity as enemy commanders realized that destroying Khe Sanh's surface installations wasn't eliminating the base's defensive capabilities. Radio intercepts captured North Vietnamese confusion. American position becoming stronger despite continuous bombardment. Underground construction proceeding faster than destruction of surface facilities. The siege lasted 77 days. When it ended on April 8, 1968, Khe Sanh had withstood over 100,000 rounds of artillery and rocket fire. The base that should have been destroyed in the first week had become stronger with each passing day. American casualties were remarkably light considering the intensity of the bombardment. 274 killed compared to an estimated 10,000–15,000 North Vietnamese casualties. The rapid construction techniques that had been perfected at smaller fire bases had saved thousands of American lives. The defense of Khe Sanh proved that American engineering had fundamentally changed the rules of siege warfare. What had been a traditional tactic of surrounding and destroying enemy positions through bombardment was now ineffective against bases that could rebuild faster than they could be destroyed. General Giap's massive gamble had failed, and American combat engineers had proven their rapid fortress construction could withstand anything the enemy could throw at them. The success at Khe Sanh sent shockwaves through Viet Cong and North Vietnamese command structures. For 3 years, they'd watched American engineering capabilities evolve from vulnerable camps to impregnable fortresses. Now, they faced a brutal reality. Their traditional tactics were obsolete. Charlie's first adaptation was timing. If Americans could build fortresses in hours, then attacks had to come during those critical construction windows. Viet Cong intelligence networks shifted focus from monitoring completed bases to tracking helicopter construction flights. Colonel Duke, who'd failed at Firebase Charlie, developed new tactical doctrine. We cannot wait for Americans to finish building. We must hit them while bunker sections are still in the air, before defensive positions connect. The results were immediate and deadly. Viet Cong mortar teams began targeting helicopter landing zones during construction operations. Anti-aircraft weapons were repositioned to create interlocking fire zones around strategic hilltops where Americans might build fire bases. Staff Sergeant Romano experienced the new tactics firsthand at Firebase Echo. Charlie was waiting for us. Soon as the first sky crane appeared, mortars started dropping on the landing zone. They weren't trying to overrun the position, they were trying to stop us from building it. The psychological warfare escalated dramatically. Viet Cong fighters would position themselves within sight of construction sites, taking potshots at engineers to slow down the building process. Every delayed minute gave Charlie more time to organize larger attacks. Sapper units received specialized training in attacking half-completed fire bases. These elite infiltrators learned to identify the most vulnerable moments during construction, when bunker sections were positioned but not yet connected, when defensive positions existed but fields of fire weren't established. Captain Rodriguez coordinated security during construction operations. Charlie figured out our construction sequence. He knew exactly when we were most vulnerable during the building process, and he'd hit us at those precise moments. The Viet Cong developed new weapons specifically designed to disrupt rapid construction. Delayed action mines were planted on hilltops where Americans might build fire bases. Booby traps were hidden in landing zones to destroy helicopter-delivered bunker sections. More sophisticated were the coordinated attacks on supply bases where prefabricated components were manufactured. Charlie realized that destroying one rear area construction facility could prevent dozens of fire bases from being built. Intelligence operations became crucial for both sides. Viet Cong agents infiltrated South Vietnamese construction crews to learn about American building techniques and schedules. Meanwhile, American intelligence worked to identify enemy positions before construction began. The race between American construction speed and Viet Cong reaction time became the defining tactical battle of the war. Engineers were building faster, but Charlie was adapting his attack timing to match American construction schedules. Radio intercepts revealed the evolution in Viet Cong thinking. American construction capabilities require immediate tactical response, cannot allow completion of defensive positions, attack during vulnerable construction phases. The most effective adaptation was coordinated multi-directional attacks during the critical first 2 hours of construction. Charlie would hit landing zones with mortars while sapper teams infiltrated partially completed perimeters and sniper teams targeted key personnel directing construction operations. These new tactics forced American engineers to develop counter-adaptations. Security perimeters had to be established before construction began. Artillery support was pre-positioned to provide immediate fire support for construction sites. Combat engineers started, carrying rifles alongside their construction tools. The escalation transformed firebase construction from engineering operations into combined arms battles. What had been construction sites became active combat zones where building and fighting happened simultaneously. By late 1968, the tactical evolution had reached a deadly equilibrium. American engineers could still build fortresses rapidly, but they paid a higher price in casualties during construction. Charlie could disrupt some construction operations, but he couldn't stop the overall transformation of American defensive capabilities. The Viet Cong had adapted to American speed, but they couldn't overcome American engineering superiority. The war had become a contest between construction innovation and destruction tactics, with both sides pushing their capabilities to the absolute limit. May 15, 1968. Firebase Ike was supposed to be the perfect demonstration of American rapid construction techniques. Located on a strategic ridge overlooking the A Shao Valley, this firebase would control one of the most important infiltration routes from North Vietnam into South Vietnam. Everything that could go wrong did go wrong. The operation began normally at LOA 600 hours. CH-54 Sky cranes approached the hilltop, carrying the first wave of prefabricated bunker sections. Intelligence reports indicated light enemy activity in the area. The construction timeline called for a fully operational firebase within 8 hours. Charlie had other plans. The Viet Cong had learned from their failures at Firebase Charlie and other rapid construction sites. This time, they'd positioned a full battalion around Firebase Ike's hilltop 3 days before American construction began. They'd studied the terrain, pre-positioned mortars, and planned coordinated attacks timed to hit during the most vulnerable construction phases. The first Sky crane was still approaching the landing zone when 82mm mortars started dropping with deadly accuracy. The helicopter pilot, Chief Warrant Officer Patterson, tried to maintain his approach while explosions erupted around his aircraft. "We were taking heavy fire before we even reached the hilltop," Patterson later reported. Charlie had the entire landing zone pre-registered for mortar fire. Soon as we appeared, they started dropping rounds right on top of us. The first bunker section never made it to the ground. A direct mortar hit on the Sky Crane's cargo load destroyed the 8-ton command bunker while it was still suspended beneath the helicopter. Patterson fought to control his aircraft as debris and shrapnel tore through the rotor system. The helicopter crashed on the landing zone, blocking access for follow-up construction flights. Worse, the wreckage was burning, sending up smoke that marked the exact location for enemy gunners positioned throughout the surrounding hills. Combat engineers hit the ground under intense fire. Instead of beginning construction operations, they found themselves fighting for survival while trying to establish a defensive perimeter around the crashed helicopter. Staff Sergeant Williams was with the 1st Ground Team. We went from construction mission to combat mission in about 30 seconds. Charlie was all over us before we could get the first fighting position established. The tactical situation deteriorated rapidly. Without the prefabricated bunker sections, engineers had to revert to traditional construction methods, digging fighting positions by hand while under constant mortar and small arms fire. The 48-hour vulnerability window that American engineers had worked so hard to eliminate suddenly became a death trap. Combat engineers were exposed on open ground, trying to build defensive positions using World War II techniques while facing an enemy who'd had days to prepare. Captain Morrison coordinated the defense. Everything we'd learned about rapid construction was useless. We were back to digging foxholes with entrenching tools while Charlie pounded us with mortars. It was like stepping back in time to the worst days of early Vietnam. The second wave of helicopters couldn't land. The burning wreckage blocked the primary landing zone, and enemy fire was too intense for pilots to attempt alternative approaches. The construction materials and defensive positions that should have been operational within hours remained stacked at the rear base. By noon, Firebase Ike was a disaster. 12 combat engineers were dead, 23 wounded, and the position was barely defensible. The hilltop that should have been a fortress was just another vulnerable American position getting pounded by enemy fire. The psychological impact was devastating. American forces throughout Vietnam had grown accustomed to rapid firebase construction success. Firebase Ike proved that Charlie could still win if he adapted his tactics and chose his timing carefully. Radio intercepts revealed Viet Cong's satisfaction with their tactical success. American rapid construction defeated through coordinated attack during vulnerable phase. Recommend similar tactics against future construction operations. The failure at Firebase Ike forced a complete reassessment of American construction procedures. Engineers realized they'd become overconfident in their rapid building techniques. Charlie had studied their methods, identified weaknesses, and exploited them with deadly effectiveness. Colonel Ploger's after-action report was brutally honest. Firebase Ike demonstrates that our construction innovations are not foolproof. Enemy adaptation requires constant evolution of our techniques and security procedures. The lessons learned at Firebase Ike would save lives at future construction sites, but the cost of those lessons was measured in American blood spilled on a Vietnamese hilltop that should have been a fortress. The statistics tell part of the story, but they can't capture the reality of what combat engineers faced in Vietnam. These men had the highest casualty rates of any military occupation specialty in the war. Higher than infantry, higher than special forces, higher than helicopter door gunners. The reason was simple. They had to work in the open while everyone else could take cover. Sergeant First Class Bobby Martinez survived 3 firebase construction operations before shrapnel from a mortar round ended his war. You'd be positioning a bunker section, totally exposed, while Charlie dropped mortars on your head. No foxhole to jump into, no bunker to hide behind. Just you, 8 tons of concrete, and incoming fire. The psychological pressure was unlike anything experienced in previous wars. Combat engineers had to maintain focus on precise construction tasks while under constant threat of death. A mistake in bunker positioning could get your entire squad killed. A miscalculation in defensive fields of fire could doom the whole firebase. Staff Sergeant Tommy Chen worked construction operations from Firebase Alpha through the final days of American involvement. You'd be guiding a Sky Crane pilot over radio while sniper rounds cracked past your head. One wrong instruction and that helicopter crashes with your buddies inside. The pressure was incredible. The physical demands pushed men beyond human limits. Combat engineers worked 18-hour shifts during firebase construction, often without sleep, food, or water breaks. They'd dig fighting positions by hand when prefab sections weren't available, then immediately transition to operating heavy equipment under fire. The worst part was watching friends die while trying to save American lives through better construction. Every combat engineer understood that faster building meant fewer casualties for everyone else, but they paid the price for that speed with their own blood. Private First Class David Kim was 19 when he died at Firebase Delta, crushed by a bunker section when mortar fire hit the Sky Crane carrying his construction team. Davey was guiding that load into position when Charlie's mortars bracketed the landing zone, his squad leader remembered. Kid never had a chance to run for cover. The trauma went beyond physical wounds. Combat engineers developed a unique form of combat stress. They were simultaneously builders and fighters, creators and destroyers. They'd spend days building defensive positions, then watch those same positions get overrun because construction hadn't been fast enough. Captain Williams, who led engineer teams at 6 different firebase construction operations, described the mental toll. You'd build something beautiful, a perfect defensive system that could save hundreds of lives. Then, you'd watch it get blown apart by mortars while you were still working on it. Part of you died with every position that didn't get finished in time. The brotherhood among combat engineers was forged in concrete and blood. These men depended on each other for survival in ways that went beyond normal military camaraderie. When your buddy was guiding a 10-ton load into position, his life depended on your ability to spot enemy movement and return accurate fire. The pride was real, despite the cost. Combat engineers knew they were revolutionizing military construction under the worst possible conditions. They were saving American lives through engineering innovations that would influence military construction for generations. But the price was measured in Purple Hearts, Silver Stars, and too many body bags filled with young men who'd volunteered to build fortresses while other people shot at them. These weren't just construction workers who happened to be in a war zone. They were combat soldiers who understood that their hammers and bulldozers were weapons in the fight against an enemy who wanted to kill every American in Vietnam. By late 1968, American combat engineers had achieved something that military theorists said was impossible. They'd compressed months of traditional construction into hours of rapid deployment. But the real revolution wasn't just speed. It was the complete transformation of how military engineering approached combat construction. Computer-aided design was making its first appearance on Vietnamese battlefields. Engineers at rear bases used early IBM mainframe computers to calculate optimal bunker placement, artillery positioning, and defensive fields of fire before the first helicopter left the ground. Lieutenant Colonel Stevens coordinated the computer design operations. We'd input terrain data, enemy threat assessments, and mission requirements into the computer. 6 hours later, we had complete construction blueprints optimized for that specific hilltop. This wasn't just faster planning. It was mathematically perfect planning. Every bunker position was calculated for maximum defensive effectiveness. Every communication line was routed for redundancy. Every supply route was designed to minimize exposure to enemy fire. The prefabricated construction systems had evolved far beyond the simple modular bunkers used at Firebase Alpha. By 1968, engineers were deploying complete fortress components that included integrated electrical systems, climate control, and communication networks. The bunker sections themselves represented cutting-edge materials science. Reinforced concrete was mixed with new polymer additives that increased blast resistance while reducing weight. Steel reinforcement used high-strength alloys developed for aerospace applications. Staff Sergeant Rodriguez worked with the advanced bunker systems. These weren't just concrete boxes anymore. They had built-in air conditioning, filtered ventilation systems, and electrical outlets already wired. You could plug in radio equipment the minute the bunker was positioned. The steel landing mat technology had revolutionized beyond simple airstrip construction. Engineers developed interlocking mat systems that could create helicopter pads, equipment storage areas, and even temporary bridges over streams and ravines. More importantly, the mats were designed for multiple uses. The same steel sections that created airstrips during construction could be reconfigured as bunker roofing, equipment platforms, or defensive barriers depending on tactical requirements. Helicopter logistics had reached levels of sophistication that amazed even the pilots flying the missions. CH-50 Outdoor Sky cranes were equipped with precision load positioning systems that allowed them to place bunker sections within inches of their intended locations while hovering in combat zones. Chief Warrant Officer Patterson described the technological advancement. We had load positioning computers that calculated wind drift, aircraft movement, and cargo swing. I could drop an 8-ton bunker section exactly where the engineers needed it while taking small arms fire. The ammunition storage systems represented another quantum leap in military engineering. Instead of traditional powder magazines that required extensive excavation and construction, engineers deployed modular storage containers with integrated climate control and automated inventory systems. These containers could be buried and operational within 2 hours of delivery. Each unit included blast-resistant construction, chemical detection systems, and remote monitoring capabilities that allowed commanders to track ammunition supplies in real time. Communication systems had evolved into integrated networks that connected every position within a firebase and linked each base to the broader military command structure. Hardened fiber optic cables replaced vulnerable radio communications for critical command functions. The psychological impact on both American forces and enemy fighters was profound. American soldiers watched mud turn into fortresses with the precision of Swiss clockwork. Viet Cong fighters found their traditional tactics useless against defensive systems that seemed to materialize from thin air. But the most important revolution was doctrinal. American military engineering had abandoned the World War II mentality of building permanent installations over months in secure rear areas. Vietnam engineers built temporary fortresses in hours while under fire in hostile territory. This transformation influenced construction techniques far beyond military applications. The prefabricated systems, helicopter logistics, and rapid assembly methods developed in Vietnam would revolutionize civilian construction, disaster response, and emergency infrastructure development for decades. The technology that emerged from Vietnamese jungles represented American industrial innovation under ultimate pressure. When engineers needed to build the impossible, American ingenuity delivered solutions that changed military construction forever. By 1969, the transformation was complete. What had taken months now took hours. What had been vulnerable now became impregnable. American engineers had turned the science of rapid construction into an art form perfected under fire. November 3, 1968, the hilltop-designated X-ray in the Central Highlands was about to become the masterpiece of American military engineering in Vietnam. Everything learned from 3 years of rapid construction failures and successes would be applied to create the perfect firebase. The location was strategically crucial. A commanding ridge overlooking the Ia Drang Valley, where American forces had fought their first major battle against North Vietnamese regulars in 1965. This time, instead of temporary landing zones, engineers would build a permanent fortress that could dominate the entire valley. Colonel Plosier personally supervised the X-ray construction planning. After Firebase Ike's disaster, he wasn't taking any chances. Intelligence teams spent 2 weeks studying the target hilltop. Aerial reconnaissance flights mapped every tree, every rock, every potential enemy position within 5 miles of the construction site. The pre-construction phase was unlike anything attempted before. B-52 strikes pounded suspected enemy positions for 3 days before construction began. Artillery from existing fire bases fired harassment missions around the clock to keep Charlie away from the hilltop. Special Forces teams established observation posts on surrounding ridges to provide early warning of enemy movement. At 0500 hours on November 3rd, the construction operation began with surgical precision. The first wave wasn't helicopters carrying bunker sections. It was gunships that swept the hilltop and surrounding areas with devastating firepower, while engineers fast roped onto the landing zone. Staff Sergeant Chen was with the advance team. "We hit the ground shooting. No construction until the hilltop was completely secure. Charlie wasn't going to catch us building this time." The security perimeter was established within 30 minutes using portable defensive positions that had been developed specifically for rapid deployment. Combat engineers carried lightweight bunker sections that could be assembled by hand in minutes, creating instant fighting positions while heavy construction began. The second wave brought the sky cranes carrying advanced bunker systems that represented the pinnacle of prefabricated military construction. These weren't the simple concrete boxes used at Firebase Alpha. They were sophisticated defensive positions with integrated fire control systems, climate control, and communication networks. Captain Rodriguez coordinated the bunker placement. Every position was pre-calculated by computer. We knew exactly where each bunker went, how it connected to adjacent positions, and what fields of fire it would cover before the first helicopter landed. The construction sequence flowed like a perfectly choreographed ballet. While some teams positioned bunker sections, others were laying steel matting for the airstrip. Artillery positions were being prepared simultaneously with communication installations. Every operation supported every other operation. The ammunition storage systems deployed at X-Ray were revolutionary. Instead of single large magazines that made tempting targets, engineers installed dozens of smaller storage containers throughout the firebase. Each container was buried and camouflaged, making it nearly impossible for enemy forces to locate and destroy the base's ammunition supplies. The defensive perimeter at Firebase X-Ray incorporated lessons learned from every previous rapid construction operation. Interlocking fields of fire covered every approach. Underground tunnels connected all positions. Multiple communication systems provided redundant command capabilities. But the real innovation was the construction timeline. Firebase X-Ray went from jungle hilltop to fully operational fortress in 36 hours with 0 casualties during construction. The security measures, improved techniques, and perfect coordination had eliminated the vulnerability that had plagued earlier operations. The psychological impact was immediate and profound. Viet Cong scouts reported back to their commanders that American construction capabilities had reached levels that made traditional guerrilla tactics obsolete. Charlie's confidence in attacking American positions evaporated when faced with fortresses that appeared overnight. Firebase X-Ray never experienced a successful enemy attack. The defensive systems were so perfectly integrated and the construction so rapid that Viet Cong forces couldn't organize effective assaults before the fortress was complete and operational. The perfect firebase had been built, proving that American engineering had finally mastered the art of rapid fortress construction under combat conditions. The success of Firebase X-Ray marked more than just a tactical victory. It represented the complete psychological collapse of Viet Cong confidence in their ability to challenge American defensive positions. For 3 years, Charlie had watched his tactical advantages disappear as American engineers turned vulnerable camps into impregnable fortresses overnight. The intelligence reports flooding into Viet Cong command centers told a devastating story. American positions that should have been easy targets were becoming unassailable within hours of construction beginning. The guerrilla tactics that had sustained Charlie's operations since the beginning of the war were suddenly obsolete. Colonel Duke, whose forces had failed at Firebase Charlie, summarized the psychological impact in his final report. American construction capabilities have fundamentally altered the tactical balance. Our fighters no longer believe they can successfully assault American positions. The morale crisis spread through Viet Cong units like a plague. Fighters who'd grown accustomed to hitting vulnerable American camps found themselves facing fortress systems that seemed to materialize from jungle mud faster than they could organize attacks. The confidence that sustained guerrilla operations began cracking under the weight of repeated tactical failures. Radio intercepts captured the desperation in Charlie's communications. American positions too strong, too fast, cannot penetrate defenses, request different mission assignments. The psychological warfare was working both ways. American soldiers who'd spent months feeling vulnerable in temporary camps suddenly found themselves fighting from positions that felt genuinely secure. The constant fear of enemy infiltration and surprise attacks began fading as soldiers realized their bases were actually stronger than anything Charlie could throw at them. Staff Sergeant Martinez described the transformation. For the first time in Vietnam, we weren't looking over our shoulders constantly. These fire bases made us feel like we could actually win this thing. But the most devastating psychological blow to Viet Cong morale was the speed factor. Charlie's entire tactical doctrine depended on having time to study American positions, identify weaknesses, and plan coordinated attacks. When American engineers compressed construction from months to hours, they eliminated the time Charlie needed for effective tactical planning. The guerrilla advantage that had sustained Viet Cong operations throughout the war was evaporating. Local knowledge meant nothing when American positions changed faster than intelligence could track them. Tunnel networks became useless when American fire bases controlled key terrain before Charlie could dig effective approach routes. Viet Cong fighters began requesting transfers to units operating away from American firebase construction zones. The psychological pressure of facing instant fortresses was breaking down the fighting spirit that had carried Charlie through years of jungle warfare. The North Vietnamese response revealed their recognition of the psychological crisis. Regular NVA units were increasingly assigned to missions against American fire bases because Viet Cong forces were no longer considered reliable for assaults against rapid construction positions. American intelligence officers noted the change in enemy behavior patterns. Viet Cong units that had previously shown aggressive initiative were becoming passive, avoiding contact with American forces operating from newly constructed fire bases. The psychological victory was complete when Charlie stopped attempting major assaults against American construction operations. The rapid fortress building had broken the guerrilla confidence that sustained Viet Cong tactical effectiveness throughout the early years of the war. By late 1968, the psychological transformation was irreversible. American engineers had not only built better fortresses, they had destroyed the enemy's belief in their ability to challenge American defensive positions. The war's psychological balance had shifted decisively in favor of American engineering superiority. Behind every fire base that rose from jungle mud in hours lay a logistics operation that defied everything military planners thought they knew about supply chain management. Moving millions of tons of construction materials by helicopter into hostile territory represented the greatest logistical achievement in American military history. The numbers were staggering. A single fire base required 2,000 tons of prefabricated concrete sections, 500 tons of steel reinforcement, 300 tons of electrical and communication equipment, plus ammunition, food, water, and fuel for the construction crews. All of this had to be delivered by helicopter to hilltops that were often under enemy fire. Colonel Stevens coordinated the supply operations from Saigon. We were running the equivalent of a major construction company's supply chain, except our delivery trucks were helicopters flying into combat zones. Every load had to be precisely calculated for weight, priority, and tactical necessity. The helicopter fleet supporting fire base construction grew into the largest military airlift operation ever attempted. Over 400 CH-47 Chinooks, 200 CH-54 Sky Cranes, and 600 UH-1 Hueys were dedicated full-time to construction supply missions throughout South Vietnam. The maintenance requirements alone should have made the operation impossible. These helicopters were flying maximum loads into hostile territory multiple times per day. Normal maintenance schedules called for major overhauls every few hundred flight hours. In Vietnam, some birds were flying that many hours every month. Chief Mechanic Rodriguez kept the fleet operational through mechanical miracles. We were cannibalizing parts from damaged birds to keep operational aircraft flying. These helicopters were performing way beyond their design specifications, but somehow we kept them in the air. The supply chain started in American factories where prefabricated bunker sections were manufactured to precise specifications, then shipped across the Pacific to Vietnamese ports. From there, everything had to move by truck to helicopter staging areas, then by air to construction sites. But the real logistics challenge was coordination. Every fire-based construction operation required dozens of different supply deliveries timed to arrive in precise sequence. Bunker foundations had to arrive before bunker sections. Electrical systems had to arrive with the communication equipment they supported. Ammunition had to arrive before the weapons that would fire it. Captain Morrison managed supply sequencing for multiple firebase operations. Picture trying to coordinate a dozen different construction projects happening simultaneously, except your delivery vehicles are being shot at, and your construction sites are in enemy territory. One mistimed delivery could delay an entire firebase construction. The Vietnamese supply infrastructure wasn't designed for this kind of operation. Roads were constantly cut by Viet Cong sabotage. Ports were overwhelmed by the volume of construction materials flowing into the country. Storage facilities had to be built just to handle the prefabricated components waiting for helicopter transport. The economic cost was astronomical. The United States was spending more money on construction materials for Vietnamese fire bases than most countries spent on their entire military budgets. Every ton of concrete delivered to a hilltop fire base cost more than a new automobile. But the strategic payoff justified every dollar. The rapid firebase construction was saving American lives by providing secure defensive positions. More importantly, it was changing the tactical balance of the entire war by eliminating Viet Cong advantages in jungle warfare. The helicopter supply runs became legendary among military aviators. Pilots were flying missions that pushed both aircraft and crew beyond all reasonable limits. Load calculations that should have been conservative were pushed to maximum weights. Flight schedules that should have allowed rest periods became round-the-clock operations. The psychological pressure on supply crews matched the stress experienced by combat engineers. Every delayed delivery could mean American soldiers remained vulnerable longer. Every mechanical failure could leave a fire base without critical defensive components. By 1969, the logistics operation supporting firebase construction had become a self-sustaining military-industrial complex. American factories were producing prefabricated military components specifically designed for Vietnamese jungle conditions. Shipping companies dedicated entire vessels to Vietnamese construction supply runs. The entire operation employed over 50,000 American civilians supporting the military construction effort. The logistics miracle that supplied impossible construction operations represented American industrial might adapted to guerrilla warfare. When engineers needed to build fortresses overnight, American supply chains delivered everything necessary to make the impossible routine. March 12, 1969. The hilltop designated Normandy in Tay Ninh Province would become the final masterpiece of American rapid construction techniques in Vietnam. Everything learned from 4 years of building under fire, every innovation perfected through blood and concrete, would culminate in the fastest fire-based construction operation ever attempted. The strategic situation demanded perfection. North Vietnamese forces were massing for what intelligence indicated would be a major offensive against American positions throughout the Third Corps. Fire-based Normandy would anchor the defensive line, but only if it could be built and operational before enemy forces could organize coordinated attacks. Colonel Plosier had one final chance to prove that American engineering had completely mastered rapid fortress construction. The timeline was impossibly ambitious: 18 hours from jungle hilltop to fully operational fire base, capable of withstanding regimental-sized assaults. The pre-construction phase represented the pinnacle of military planning precision. Satellite reconnaissance provided detailed topographical data that was fed into IBM computers for optimal defensive positioning calculations. Weather forecasts were analyzed to ensure perfect flying conditions for the critical construction window. Intelligence teams confirmed enemy positions throughout a 20-mile radius. At 0400 hours, the operation began with the largest helicopter assault in Vietnam War history. Over 60 aircraft participated in the initial wave. Gunships, transport helicopters, sky cranes, and command aircraft working in perfect coordination to establish American control over the target hilltop. The security phase lasted exactly 30 minutes. Combat engineers fast roped onto the hilltop, while gunships suppressed suspected enemy positions throughout the surrounding area. Portable defensive positions were assembled within minutes, creating instant fighting positions while heavy construction preparations began. Staff Sergeant Chen led the advanced construction team. We had this choreographed down to the second. Every man knew exactly what his job was, where his equipment went, and how his work supported everyone else's. It was like watching a perfectly tuned machine. The first sky crane arrived at 4:35 hours carrying the command bunker, a sophisticated prefabricated structure that included integrated communication systems, tactical operations center, and climate control. The bunker was positioned and operational within 12 minutes of arrival. The construction sequence flowed with mechanical precision. While the command bunker was being positioned, other sky cranes were delivering artillery positions, ammunition storage containers, and defensive bunker sections. Every delivery was timed to support the overall construction timeline. The steel matting for the helicopter landing zone was deployed using a revolutionary new technique. Instead of individual sections that had to be connected on the ground, engineers used pre-assembled mat segments that could be positioned in single helicopter lifts, creating an operational airstrip in minutes rather than hours. Captain Rodriguez coordinated the bunker installation. These weren't the simple concrete boxes we started with at Firebase Alpha. These were sophisticated defensive systems with integrated electrical, communication, and life support systems. You could fight from these positions for weeks without resupplying. The defensive perimeter incorporated every lesson learned from previous fire-based construction operations. Underground tunnel systems connected all positions before the bunkers were even completely installed. Communication lines were buried and operational before the first defensive positions were manned. Ammunition storage was distributed throughout the fire base in blast-resistant containers that were invisible from the surface. The artillery positions received special attention. The 105mm howitzers were positioned on pre-engineered concrete pads that provided perfect stability for accurate fire while protecting the guns from counter-battery attacks. The artillery was operational and firing registration missions within 6 hours of construction beginning. But the real innovation at Firebase Normandy was the integration of all systems into a unified defensive organism. Every bunker supported every other bunker. Every communication system backed up every other system. Every supply route had multiple alternatives. The Firebase was designed to continue functioning even if major components were destroyed. At 2200 hours on March 12th, exactly 18 hours after construction began, Firebase Normandy was declared fully operational. The fortress that had been Jungle Hilltop that morning was now capable of withstanding sustained attacks from regimental-sized enemy forces. The psychological impact on both American and enemy forces was profound. American soldiers watched Jungle become fortress with clockwork precision. Enemy observers reported that American construction capabilities had reached levels that made traditional assault tactics suicidal. Firebase Normandy never faced a major enemy attack. The defensive systems were so perfectly integrated and the construction so rapid that North Vietnamese forces abandoned their planned offensive rather than assault positions they couldn't hope to overcome. The last great construction had proven that American engineering had achieved the impossible, turning rapid fortress building into a precise military science that could guarantee tactical superiority in any terrain, under any conditions, faster than any enemy could respond. The techniques perfected in Vietnamese jungles didn't stay in Vietnam. Within months of the war's end, American military engineers were applying rapid construction methods to bases worldwide. The revolution that began with Firebase Alpha had fundamentally transformed how modern militaries approach defensive construction. The modular bunker systems developed under fire became standard equipment for American forces globally. NATO allies studied the prefabricated construction techniques and adapted them for European defensive positions during the Cold War. The speed that had saved lives in Vietnam became doctrine for military construction everywhere. Major General Patterson, who'd commanded engineer operations throughout the later war years, oversaw the transformation. We took everything we learned about building under fire and made it standard procedure for peacetime construction. Why take months to build what we could build in days? The helicopter logistics revolution spread far beyond military applications. Civilian construction companies adopted the precision, load positioning systems developed for sky crane operations. Emergency response organizations used the rapid deployment techniques to establish disaster relief operations. The methods that built fire bases overnight became tools for humanitarian operations worldwide. The computer-aided design systems that had optimized defensive positions in Vietnam evolved into the foundation of modern military engineering software. Every American military base built since 1975 incorporated design principles perfected in Vietnamese jungles. The mathematical precision that had maximized defensive effectiveness under enemy fire became standard for peacetime construction planning. But the most important legacy was doctrinal. American military engineering abandoned the World War II mentality of building permanent installations over extended periods in secure rear areas. Vietnam proved that modern warfare required the ability to establish effective defensive positions rapidly in hostile territory. The rapid construction techniques influenced civilian architecture and engineering. Prefabricated building systems developed for combat zones found applications in commercial construction, disaster relief, and emergency infrastructure development. The speed and precision that had been military necessities became competitive advantages in civilian markets. International military forces studied American rapid construction techniques and adapted them for their own requirements. British forces applied the methods during the Falklands War. Israeli engineers used similar techniques for rapid fortification construction along contested borders. The innovation that emerged from Vietnamese combat zones influenced military engineering globally. The psychological lessons proved equally important. Vietnam demonstrated that construction speed could be a decisive tactical advantage. The ability to establish secure positions faster than enemies could respond became a cornerstone of American military doctrine. Speed of construction became as important as strength of construction in military planning. The technology transfer from military to civilian applications created entire industries. Companies that had manufactured prefabricated bunker sections for Vietnam fire bases became leaders in modular construction systems. Helicopter manufacturers that had developed precision load positioning systems found new markets in civilian construction and emergency response operations. The training programs developed for combat engineers became models for military engineering education worldwide. The U.S. Army Engineer School incorporated Vietnam lessons into curricula that trained engineers from dozens of allied nations. The techniques perfected under fire became standard training for military engineers globally. The economic impact extended far beyond military budgets. The rapid construction industry that emerged from Vietnam techniques employed hundreds of thousands of civilians in manufacturing, logistics, and construction operations. The innovation that had been driven by military necessity became a significant sector of the American economy. The environmental applications proved unexpected but valuable. Rapid construction techniques developed for military operations found uses in environmental disaster response, wildlife habitat construction, and conservation infrastructure development. The methods that had built fortresses and jungles became tools for environmental protection and restoration. By 1980, the transformation was complete. Military construction that had taken months before Vietnam now took days. Defensive positions that had been vulnerable became impregnable. The engineering revolution that began with desperate American soldiers getting picked off from temporary camps had changed military construction forever. The legacy of Vietnamese combat engineers lived on in every rapid construction operation, every prefabricated building system, every helicopter-lifted load positioned with precision. Their innovation under fire had transformed not just military engineering, but the entire approach to rapid construction under adverse conditions. Bobby Martinez sits in his Phoenix living room, his weathered hands still bearing scars from Vietnamese concrete and steel. At 73, he remembers every detail of building Firebase Delta while mortar rounds exploded around his construction crew. "People ask me what it was like building those bases," Martinez says quietly. "They think we were just construction workers who happened to be in a war zone. They don't understand we were soldiers who built fortresses while Charlie tried to kill us." Martinez was 22 when he arrived in Vietnam with the 18th Engineer Brigade. He'd learned construction working on his father's ranch in New Mexico. Nothing had prepared him for guiding 8-ton bunker sections into position while enemy snipers targeted the Sky Crane pilots hovering overhead. "The worst part wasn't getting shot at," he continues. "The worst part was knowing that if we screwed up, if we didn't get those bunkers positioned right, American boys were going to die because of our mistakes. That pressure never left you." Tommy Chen operates a construction company in Seattle now, but his office walls display photos from fire-based construction operations throughout 1968 and 1969. He commanded engineer teams at 7 different rapid construction sites, losing 11 men to enemy fire during building operations. "We were proud of what we accomplished," Chen explains. "We took American engineering and made it work under impossible conditions, but the cost was brutal. I lost more friends building bases than most infantry units lost in combat operations." Chen's voice hardens when he describes Firebase Ike, where everything went wrong. "Charlie caught us with our pants down. We went from construction mission to survival mission in 30 seconds. 3 of my boys died trying to establish a defensive perimeter with nothing but entrenching tools and small arms." The psychological scars run deep among fire-based construction veterans. These men experienced a unique form of combat stress. They were simultaneously creators and targets, builders and fighters, engineers and soldiers. The dual nature of their mission created trauma that military psychiatrists struggle to understand. David Rodriguez spent 18 months building fire bases before shrapnel from a 122mm rocket ended his construction career. He returned to civilian life, but couldn't handle normal construction work. The sound of helicopters sent him diving for cover. The sight of concrete mixers triggered flashbacks to Sky Cranes carrying bunker sections through enemy fire. "Civilian construction felt like playing games," Rodriguez remembers. "Nobody was shooting at us. Nobody was going to die if we took an extra hour to position a beam correctly. I couldn't adjust to construction without consequences." The brotherhood forged among combat engineers remains unbreakable decades later. Annual reunions bring together men who share the experience of building fortresses under fire. They understand each other in ways that families and civilian friends never could. We saved lives through engineering, Martinez reflects. Every firebase we built meant fewer American casualties. Every bunker we positioned correctly meant soldiers went home instead of coming back in body bags. That knowledge sustained us through the worst moments. The pride is genuine despite the trauma. These men revolutionized military construction under conditions that should have made innovation impossible. They proved that American ingenuity could overcome any tactical disadvantage when lives depended on engineering excellence. Charlie laughed at our early camps, Chen concludes. He stopped laughing when we started building fortresses overnight. We changed the war through superior construction, and we're proud of that legacy. April 30th, 1975. The last American helicopters lifted off from Saigon as North Vietnamese tanks rolled through the city streets. Behind them, scattered across the Vietnamese countryside, stood the monuments to American engineering ingenuity. Dozens of firebases that had never been successfully overrun by enemy forces. Firebase X-Ray still dominated the Ia Drang Valley, its concrete bunkers intact, its steel landing mats undamaged, its defensive positions as perfect as the day they were completed in 36 hours. Firebase Normandy remained operationally ready in Tay Ninh province, capable of withstanding regimental attacks that would never come. Firebase Charlie continued to control its strategic ridge, the fortress that had broken Viet Cong confidence in their ability to challenge American positions. The irony was devastating. American engineers had solved the tactical problem that had plagued U.S. forces throughout the early war years. They'd eliminated the vulnerability that had cost so many American lives. They'd built fortresses that could have controlled Vietnamese territory indefinitely. But military engineering couldn't solve the political problem that ultimately determined the war's outcome. Colonel Duke, the Viet Cong commander who'd failed to overrun Firebase Charlie in 1967, walked through the abandoned American positions in May 1975. The bunkers his forces couldn't capture were now his without firing a shot. The defensive systems that had seemed impossible to penetrate were empty, waiting for new occupants. The Americans built better than we ever imagined, Duke would later write in his memoirs. Their engineering was superior to anything we could have achieved, but they built permanent fortresses for a temporary commitment. The abandoned firebases became symbols of American technological superiority applied to an unwinnable strategic situation. Every bunker represented engineering excellence. Every defensive position demonstrated tactical innovation. Every firebase proved that American ingenuity could overcome any military challenge, except the challenge of political will. Staff Sergeant Martinez, who'd helped build Firebase Delta under mortar fire in 1968, watched the evacuation coverage on television from his Phoenix home. "We built those bases to last forever," he said quietly. "We thought we were building America's permanent presence in Vietnam. Turned out we were just building really expensive temporary positions." The North Vietnamese Army inherited the most sophisticated military construction in Southeast Asian history. Bunkers designed to withstand American B-52 strikes now protected communist forces. Communication systems engineered for American military networks carried North Vietnamese radio traffic. Artillery positions calculated by IBM computers now aimed North Vietnamese guns. The technology transfer was complete and involuntary. Every innovation developed by American combat engineers under fire became available to the communist forces they'd been fighting. The rapid construction techniques, the prefabricated systems, the defensive integration, all of it abandoned to the enemy. Some firebases were stripped of valuable equipment before abandonment. Steel landing mats were airlifted out for use at other locations. Communication equipment was removed and shipped to American bases worldwide. But the bunkers, the defensive positions, the engineering that had cost American lives to perfect, all of that remained. The jungle began reclaiming some positions within months. Fire-base positions in remote areas were gradually overgrown as tropical vegetation consumed the concrete and steel that American engineers had positioned with mathematical precision. Nature was slowly erasing the monuments to American engineering excellence. Other fire bases found new purposes under communist control. Fire-base Normandy became a training facility for North Vietnamese Army engineers studying American construction techniques. Firebase X-Ray was converted into a supply depot supporting communist operations throughout the Central Highlands. The most bitter irony was that the engineering innovations developed in Vietnam continued influencing military construction worldwide, while the fire bases themselves served America's former enemies. NATO bases built using Vietnamese techniques protected Western Europe, while the original Vietnamese positions protected communist forces. Bobby Martinez returned to Vietnam in 1995 as part of a veteran tour group. He found Firebase Delta overgrown with jungle vegetation, its bunkers cracked but still intact 20 years after abandonment. The defensive positions he'd built under enemy fire had outlasted American involvement in Vietnam. Those bunkers were built to protect American soldiers for decades, Martinez reflected, standing in the ruins of his engineering achievement. Instead, they became monuments to a war we couldn't finish, no matter how well we built our positions. The abandoned fire bases represented the ultimate limitation of military engineering. American combat engineers had achieved the impossible, building fortresses overnight under enemy fire. But engineering excellence couldn't overcome strategic failure. The best-built positions in military history became the enemy's inheritance when political will collapsed. The fire bases that rose from Vietnamese mud in hours revolutionized military construction worldwide, proving that engineering speed could be as decisive as firepower in modern warfare. Combat engineers who built fortresses under fire created techniques that influence military construction today, from rapid deployment bases to emergency disaster response. Their innovation under impossible conditions changed how armies approach defensive construction forever. If you want to see how these Vietnam techniques influenced modern military operations, check out our video on rapid deployment bases in Iraq and Afghanistan. Subscribe for more untold stories of military innovation.